Hey guys, welcome back to my YouTube channel. Today I'm going to be talking about integration by parts. So let's say you have an integral that looks something like this, right? Something like this, okay? Somewhat in this form. The formula says that you can multiply u times v, right? And then you can subtract the integral of v times du, like that. So this is like the formula we're going to be using when we do integration by parts to evaluate an integral that looks something like this. So say we have an example that looks something like this, and we're trying to find the integral of this, and we have to use integration by parts. So we can look at it and we can see we have two parts, right? We have a part right here, yeah, and we have a part right here. Okay, so we basically, the formula, recall, was basically the integral of u times dv is equal to uv minus the integral of v times du. So here we can let one of these be u and one of these be dv, right? Well, the dv has to include the dx, by the way, so you can have this, okay, and this be dv, that's an option. But here we realize that we should let this be u, okay? This should be u because the trick to finding the u is to see when you find that u, the derivative of u has to be simpler. So let's say we let this be u, right? So let's say we let u be equal to x to exponent 3 minus 3, right? Our du over dx, which is the derivative, is going to be basically 3x squared, right? Using power rule, so 3x squared. And 3x squared is simpler than this, x cubed minus 3, because this exponent basically becomes 2, and this is 3, it goes down, right? So the trick to finding the u is to find something that the derivative will be lower and exponent will be simpler, okay? If we let e to exponent of x be u, the derivative of e to exponent of x is itself, and that doesn't make it simpler. So it's better to let u be equal to x cubed minus 3, okay? I will explain more on that a little later. So anyway, so we let u be this. Now our dv, what do we need to let our dv to be? So we have to let our dv to be the other part, right? So this is our u, okay? So this is our u, and this will be our dv, this other part. So we let our dv be equal to e to the exponent of x times dx, okay? And so this would mean that this, right, if we move this to the other side, divide both sides by dx, it would be equal to e to the exponent of x. So this is the derivative. Now we have to find the original function of the derivative, right? So like integration, so we have to integrate this, and that's going to give us e to the exponent of x, because the derivative of e to the exponent of x is itself, so that's why v is equal to e to the exponent of x, which was like the original function. You can think of it that way, quote unquote. Anyways, so now we got these parts, okay? And now we can substitute it in. So we have to substitute in, u times v, right? So we have to find our u is this, right? U is x cubed minus 3, okay, this is our u, and then times v is e to the exponent of x, so I'm going to sub that in, right? Because we have to write u times v, okay? So u is here, times v, right? And then now copy the subtraction sign, and then the integral of v times du. So v is e to the exponent of x, so I'm going to write e to the exponent of x, and then du is well, here du over dx is 3x squared, so if you rearrange and you multiply both sides by dx, right, then your du is going to be equal to 3x squared times dx. So this is going to be 3x squared times dx, just like that. So now what we can do is we can basically integrate this part now because we still have the integral sign. Obviously, that doesn't solve the problem. We need to integrate it fully, right? To get rid of this integral sign and the dx. So we have to do this part now. Okay, so here, let's just rewrite this, make it look nicer first. Minus, this will be 3x squared times e to the exponent of x, right? Dx, and we can bring this 3 out. Notice that. So I'm going to bring that 3 out. And this is going to be minus 3 times the integral of x squared times e to the exponent of x dx. Okay, so now we have this, okay? So now we have to use integration by parts again. We have a part here and a part here. And I would like to let u be equal to x squared because I know it's going to be simpler when we differentiate that. So we're trying to get this form again. So this is the second time we're doing it. So I'm going to draw a line. And our u, we are letting it be equal to x squared. And then that would mean that du over dx is going to be equal to 2x, right? See how it's simpler? The derivative is simpler, and that's what we want, okay? For u, derivative has to be simpler. That's the trick, okay, to finding what u should be equal to, okay? Now this is our u, this is dv. dv is going to be equal to, dv is equal to e to the exponent of x times dx. So e to the exponent of x times dx. And then from here, we have to find v, right? Now that would mean that dv over dx is equal to e to the exponent of x because we divide both sides by dx, right? So our v, as mentioned before, right, is going to be e to the exponent of x because the derivative of e to the exponent of x is just itself, okay? So we have found these parts, and now we are going to sub them in. So we need to copy this first. This part is -3, and then we're finding the integral of this. So I'm going to put it all in square brackets. So we have to sub in our u, right? Remember, from the formula, it's u times v. So I'm going to sub in our u and our v. So our u in this case is x squared. Our v in this case is e to the exponent of x. So x squared times e to the exponent of x. And then minus, right? The minus comes from here in the formula. The integral of v times du. So we're going to sub that in. So the integral of v, which is ex, right here, integral of ex, and then du. du, well here du over dx is 2x, so that would mean if we multiply both sides by dx, like this, du is going to be equal to 2x times dx. So I'm going to write here 2x times dx, okay? And the square bracket right here basically represents this part right here, okay? I'm putting around brackets, right? This part right here that I just drew round brackets around is basically the part that's inside the square brackets. Alright, so the next part we have is we need to integrate this part, right? But first let's use the distributive properties, simplify things further just to make it easier for us. So I'm copying this, then -3. I'm going to distribute this -3 to each one, so -3 x squared ex, right? I distribute here. Now I distribute to the next one, so it's going to be +3 because negative and negative make a positive. So +3 times the integral of ex times 2x dx, like that. And then from here we can see that we have a 2 here, so we can take this 2 out. Okay, so I'm going to do that. So copying all this, taking the 2 out, 2 times 3 is going to be 6. So it's going to be 6 here, and then times the integral of e to the exponent of x times x dx, like that. So now we have this, okay? We can use integration by parts for a third time. So here we can let x be u because we know that basically the derivative of x is going to be simpler. It's just going to be 1, right? And then here we can let these two parts be dv. So these two parts are going to be dv. So using integration by parts for the third time, we have our u to be equal to x as shown here, and dv is equal to e to the exponent of x times dx from here, right? And so u is equal to x, so that means the derivative of u, right, du over dx is basically 1, so that means du equals dx, okay, because we are multiplying both sides by dx like this. Cancel, cancel, that's how we get du equals dx. And then from here we know dv over dx, right, we're dividing both sides by dx. This is going to be e to the exponent of x, right? And then, since this is a derivative, we know that to find the original one, well, the derivative of e to the exponent of x is basically e to the exponent of x, so the original one is going to be e to the exponent of x. So this is our v, and so now from here, carrying on, we have to copy this. Plus 6, and then here, let's write this in square brackets, okay? So we have to sub in our u, right? As shown before, our u times our v, right? So we are integrating this portion, so u is going to be x. So I'm going to sub in my u, okay, this is my u, times my v, which is e to the exponent of x. And then from this equation, we did our u and our v. Good, now subtract. So now we have to subtract the integral of v, right? Because here says v, so I'm going to write v in right here. Just copying that. So v is going to be e to the exponent of x. And then my du, as shown here, is right here, right? Du, okay, well, from here, where is my du? Du is equal to dx, so I'm just going to write dx right here, like that. This is all in square brackets to indicate that we are integrating this part right here. Okay, corresponding with the square brackets. Alright, so now let's simplify this. So copying all this stuff. So 6 times x times e to the exponent of x is going to give us 6x times e to the exponent of x. Here, this is 6 times negative the integral of e to the exponent of x. 6 times negative, right? It's negative 6 times this integral, right? We're just basically using distributive property, right, to each one. Okay, so now we have this, and the integral of e to the exponent of x, as mentioned before, is e to the exponent of x, because the derivative of e to the exponent of x is basically e to the exponent of x, right? Shown from before. So this is going to be, let's copying this first. Minus 6, so this is going to be e to the exponent of x, simply. That's the integral. And then when we get rid of the integral sign, it means we need to put this constant right here. So now there we have it, and to make this look even better, we can simplify it more by factoring e to the exponent of x out. So here, x cubed minus 3, right, we got this. Now factor this one out. So we are left with negative 3x squared, because we factor this one out. And then here we will be left with positive 6x, because we factor this e to the exponent of x out. And then here we factor e to the exponent of x out again, so negative 6 will be left. So we basically factored all of these out, right? All of these e to the exponent of x's. And so this is all in brackets, plus c, right? We factored it out and placed it here. And then, you can simplify it more, we have like terms. So this and this can be combined, so x cubed minus 3x squared. I'm just putting it in descending power, so I got this, plus 6x. Negative 3 minus 6 is negative 9. And there we have it. So this is basically how we integrate it by parts for this question. So with this question, let's say we did it differently. Like, let's say we, instead of letting this part be u and letting this part be dv, instead we chose e to the exponent of x as our u and this part and dx as our dv. So what I mean is, so we have that question, right, this was our question. So let's say instead of letting this part be u, okay, we let this part be u, and this part here, and this part here be our dv. So I'm drawing a line here, so we did this question differently. So let's say our u is e to the exponent of x, okay, as shown here. Our dv is, let's say, our dv is equal to x cubed minus 3 times dx, okay? And remember, this integration by parts is supposed to be integral of u times dv equals uv minus the integral of v times du. And so this part here, right, this part is equal to our u times dv's, right? This part is u times dv. Okay, so now we have to find v, and we have to find du over dx. So du over dx, right, it's going to be equal to e to the exponent of x. Du is going to be e to the exponent of x times dx, because we multiply both sides by dx. And then here, our v, right, we're going to find v. dv over dx is equal to x cubed minus 3. So we're trying to integrate this. So integrating this, we are going to get x to the exponent of 4, right, using power rule for integration. So x to the exponent of 4 over 4, and then this is minus 3, so it's going to become minus 3x. Okay, so now let's plug everything in. So u times v, u is e to the exponent of x times our v, which is this whole thing right here, minus the integral of v times du. V is this here, so I'm going to plug that in. V is this. And then du is equal to e to the exponent of x times dx. Okay, well look at this. Now look at what we have to integrate here. This looks way more complex. The power here is higher, okay, and there's another x here. Oh my goodness, this is looking a little bit harder than this, right? It's just making things more complex for us. I mean, equating these isn't wrong, but you wouldn't want to integrate something like this. We're trying to make it easier. That's why we have to choose our u, right? Our u that we choose has to have a simpler derivative. Okay, so that's why I did not choose our u to be equal to e to the exponent of x. So that's just a little side note there. Okay, so now say we have a question that looks something like this, okay? This question requires a little bit of a different approach. So if we choose, let's say, u to be equal to cos 2x, right? We're going to get like a derivative. Well, what's a derivative of cos? Well, the derivative of cos is going to become, negative sign, right? And the 2 is just some sort of constant. It's going to be brought out and stuff like that. And when it's brought out, it's not really affecting it. And e to the exponent of 5x, well, it's just going to be stuck with this form. Well, okay, well, let's just try and see what happens, okay? And I'll show you it actually magically works. Okay, so let's just choose, in this case, let's choose this to be equal to u, and let's choose this part to be equal our dv, okay? So this one is a little bit of a different approach. So normally you would choose a u that makes it simpler, but it's not really a simpler derivative for any of them. So that's why we have really no choice. So I'm just going to choose one of them, okay? So u is going to be e to the exponent of 5x, right? So we let our u be equal to e to the exponent of 5x. And as mentioned before, our derivative is not as simpler. It's basically 5 times e to the exponent of 5x, right? That's using the chain rule, okay, for finding the derivative. See, it's not really simpler. The du over dx is not simpler. And by the way, the form we had was u times dv equals uv minus the integral of v times du, like that. Okay, so anyways, let's get back to work. So u is equal to this, dv is equal to that. So let dv be equal to cos 2x dx. Okay, and then we can see that dv over dx is equal to cos 2x. And that's a derivative, so we're going to have to integrate this to find v, right? What's v equal to? We don't know. So what I'm going to do, I'm going to take another line and I'm going to find an integral of this. So the integral of this, right? So we can find v, okay? So the opposite of differentiation is basically integrating, so I'm going to integrate this. Okay, and integrating this, well, we can use a substitution. Okay, so we can basically let w be equal to x right here. That's 2x, so it's going to be cos w, and then dx, what are we going to get? Well, the derivative of w is going to be dw over dx, which is equal to 2. And then we can multiply both sides by dx. And then dw is going to be equal to 2 times dx. Now from here we can isolate for dx, so we're going to divide both sides by 2 like that, and then dx is going to be equal to dw over 2, right? Because these cancel, dx equals dw over 2. So yeah, I'm going to sub that in to dx. So this was the separate part, I'm just going to draw a line here. Okay, so dx is going to be equal to dw over 2, and this is over 2, so I'm going to take that out, the constant 1 over 2 times the integral of cos w dw, and the integral of cos, we know that the derivative of sine x is equal to cos x. Okay, and we're integrating it, so we're trying to find what it was before being a cos, right? So basically, if we integrate cos w, it's going to be sine w, right? So it's going to be 1 over 2 times sine w right here, and plus the constant c. But for v, we don't write the constant c, so I'm just going to write 1 over 2 times sine, well, what was w? Well, it was actually 2x, so I'm going to write sine 2x plus c, so this is going to be sine 2x, like that. Okay, so this is our v. Okay, so now we're going to sub stuff in. So u is going to be equal to e6.5x, and then v is equal to 1 over 2 times sine 2x, okay, as shown right here, so u times v, and then minus the integral of this, right, v, a half sine 2x, so a half sine 2x, and from here that was v, right, we subbed in v, and then now subbing in du, we have basically, well, this is du over dx, right, so I'm going to multiply both sides by dx, so we can isolate for this du. So du is equal to 5 times e to the 5x times dx. So I'm going to write in, it's going to be 5 times e to the exponent of 5x times dx from here. Okay, so that is my du, right, because du is equal to that, so bring that in. And then we can simplify this a bit more. So 1 over 2 times e to the exponent of 5x times sine 2x. And then from here I can take out these constants, negative a half, right? And this 5, I could take it out. So 5 times a half is going to be 5 over 2, times the negative is going to be negative 5 over 2. And then the integral of what's here, right, what's left, so sine 2x times e to the exponent of 5x times dx. And so now what we have to do is we need to integrate this new part, okay? So to do that, we can let our u be equal to e to the exponent of 5x just like we did before. This is our u, and then this part here is part of our dv, so these are going to be a dv. So u is equal to e to the exponent of 5x, and then we also let our dv be equal to sine 2x times dx as shown right here. So I'm going to let my dv be equal to sine 2x times dx, sine 2x times dx right here. So now from this we can find our derivative du over dx, and that is equal to 5 times e 5x using the chain rule, right? We have 5x here, so finding the derivative of 5x, we get 5. Now this is dv is equal to this, right? And there's a dx here. Let's divide both sides by dx. So dv over dx is equal to sine 2x. And then since this is a derivative, we need to find v, right? Which means we need to integrate to find v. So we have to integrate sine 2x. So finding the integral of that, so integral of sine 2x dx. We have to use a substitution, so let's let w be equal to 2x, okay? So let w be equal to 2x, so it's going to be the integral of sine w, and now that's dx. Well, let's look at dx. We have to find a derivative of this, so dw over dx is equal to 2, and then we have to substitute this something in for dx. So dw equals 2 times dx, so we multiply both sides by dx, right? That's how we get this part. This cancels, and then we can divide both sides by 2 to isolate for dx, so we can substitute this in. So dw over 2 is equal to dx. So dx is equal to dw over 2, so we can substitute this dx, right, with dw over 2. So dw over 2 goes right here. And then here, this is over 2, right? This is a constant, this is a half. So I'm going to take that out of the integral sign to make things easier for us. So it's going to be 1 over 2 times the integral of sine w, okay? And then copy dw. Okay, so from here, we need to find the integral of sine w. So firstly, well, let's think of it this way. We know the derivative, right? The derivative of cos x is going to be equal to negative sine x, right? Now, how about the derivative of negative cos x? The derivative of negative cos x is going to be negative times negative sine x, which here we have 2 negatives, so it's going to be a positive, so it's going to be positive sine x, which is just equal to sine x. So here the sine w, right, we're trying to find the integral of that, opposite of differentiation. So that means it will be negative cos w, right? Negative cos w. So we're going to get 1 over 2 times negative cos w, just like that, plus see the arbitrary constant that we have to put in when we integrate. So after this arbitrary constant, and then here we have negative a half times cos w. What's w? W was 2x, so we're going to sub that back in, plus c, like that. And then here, we don't need to write the arbitrary constant, and so we just write negative a half cos 2x for v, and so we got our v. So now we are going to integrate by parts. So subbing everything back into this expression, here we have 1 over 2 e to 6.5x times sine 2x minus 5 over 2 times, now this integral, right? So we're going to sub in what we had. So our u's and v's, dv and du. So first we have to put in u and v, u times v. So what's u? U is e to exponent 5x. So I'm going to write in e to the exponent of 5x. And then we need to multiply by v. So v is going to be equal to negative a half cos 2x, negative a half cos 2x for v. And then we have to subtract, right, as shown in the formula right here. And then we have to write the integral sign. And we need to sub in v and du as shown here in the formula. So we're going to write in v and du. So v is negative a half cos 2x, negative a half cos 2x. So we got our v. And for du, we have to write in, well, here we see du over dx is equal to 5 times e to the exponent of 5x. So we have to multiply both sides by dx, right, to get our du. So here, cancel, cancel, du is equal to 5 times e to the exponent of 5x times dx. So I'm going to write that in for the du. So du is equal to 5 times e to the exponent of 5x times dx. As shown from here, du is equal to this, right? So now what we're going to do is we are going to write in the square bracket to show that we have finished this part, right? This is the integral of this. So now we are going to simplify, so it's going to be half times e to the exponent of 5x times sine 2x minus, oh, and we can also use a distributive property, but actually before that, let's simplify the other stuff first. It's going to be 5 over 2 times, this is negative a half. Negative a half times e to the exponent of 5x times cos 2x. And then here it's 5 and negative a half. We can bring these out, right? They're basically constants. So bring them out. So negative, two negatives, right? A negative here and a negative here makes a positive. So it's going to be positive. 5 times a half is 5 over 2. So I'm going to write 5 over 2 right here. And then the integral sign. And then basically everything else. So cos 2x times e to the exponent of 5x. Just like that. And then dx like this, and then close square bracket. So from here, I'm just going to copy this term right here. So 1 over 2 times e to the exponent of 5x times sine 2x right here. And then we have to apply the distributive property of negative 5 over 2 to each of these terms. So negative 5 over 2 times this one, right? Negative a half times e to the exponent of 5x cos 2x. And then from here, negative 5 over 2 times 5 over 2. I'm just going to combine it and just say that 5 times 5, well, that's going to be 25. Right, 2 times 2 is going to be 4, and I have a negative here because there's a negative here and a positive, so it's just going to be a negative right here. And then here the integral of this, so cos 2x times e to the exponent of 5x times dx, just like that. And I'm going to simplify this a bit more. So I'm going to get 5 times 1 is going to be 5, and here negative, negative, positive, so positive 5. 2 times 2 is 4, so 4 right here, times e to the exponent of 5x, and then cos 2x like that. And here negative 25 over 4 times the integral of e, I'm just going to write the e first, e to the exponent of 5x times cos 2x dx. Okay, and so from here, what do we notice from here? Well, I mean, it may seem like we're going nowhere, but actually we are going somewhere. Look, so our original question was the integral of e to the exponent of 5x times cos 2x, right? It's right here. And what do we have right here? What do we have right here? Well, this expression is the same as this one right here, right? Same as this one, okay? They are the exact same thing. So what I'm going to do is recognize it, since that they're the exact same thing, we are seeing that this, right, is equal, like this expression is equal to this right here, what I am boxing in. So this line right here that I'm boxing in is basically equal to this original expression. So hey, that means we can equate both of these, right? we can equate both of these, and we can isolate for this part, the circled part, right? We can treat like a variable, isolate for it, and solve for it. And then we will basically find the answer to this. Hey, that's a great idea. Let's do that. So I'm going to rewrite this whole thing. And so rewriting that, I am going to have the integral of e to the exponent 5x times cos 2x as shown right here times dx. So I'm going to write dx right here. And this is all going to be equal to y squared in right here. So a half times e to the exponent 5x times sine 2x times sine 2x plus 5/4 times e to the exponent 5x. So I'm just copying that, plus 5/4 times e to the exponent of 5x times cos 2x, so times cos 2x, and then minus 25/4, so minus 25/4 times the integral of this, right? Integral of e to the exponent 5x, e to the exponent 5x, integral of e to the exponent 5x. It's basically the same as this, so I'm just going to copy that. Cos 2x dx. So I copied basically this whole thing. So the whole thing right here, I copied here to form a new equation. Alright, so now let's isolate for this part, right? This part. So we have basically this here, and we basically have this here, and it's a like term. So we can move this over to this side, okay? So instead of negative 25/4, it's going to become positive 25/4. So copying this here first, we get the following. Plus 25/4, right? This negative becomes positive, so positive 25/4, the integral of this. Right, and this is going to be equal to the following expression. We're just going to copy that below. So a half times e to the exponent 5x sine 2x plus 5/4 times e to the exponent of 5x cos 2x, just like that. And so now here we have like terms, right? This here we need a common denominator, and this is the same as 4/4. So now we can add these two together. 4 plus 25 is 29, so it's going to be 29/4 times that integral. This is all equal to the expression right here. And then from here, we want to isolate for this integral, right? So to do that, we basically need to get rid of 29/4 from this side. Well, how do we get rid of 29/4? Well, we have to recognize that the fraction, if we multiply the reciprocal of that, right? If we multiply this by the reciprocal, 4/29, right? Then this here is going to cancel with this. This here is going to cancel with this, and we're going to be left with this, right? So we have to multiply by this on this side, but we must also do it on the other side, so we're going to multiply that. So multiplying this side by 4/29, and here we get the integral of e to the exponent 5x cos 2x dx is going to be equal to this, right? This expression. You can even use distributive property to make it look nicer. So distribute here and here. So 4/29 times 1/2 times e to the exponent 5x sine 2x is multiplying it by this term, and then multiplying it by the second term, so 4 over 29 times this expression, 5 over 4, e to the exponent of 5x cos 2x. And now we can just simplify this, so divide by 2, we get 2 here, divide by 4, so cancel. And this here basically gives 2 over 29 times e to the exponent of 5x sine 2x plus 5 over 29 times e to the exponent of 5x times cos 2x. And then we can factor out e to the exponent of 5x over 29 just to make it look nicer. Right, we can do that. So factoring that out, 1 over 29 times e to the exponent of 5x is being factored out. Okay? And so we will be left with 2 times sine 2x right from here, and this is factored out. And then plus 5 times cos 2x like this. And so our final answer, right, we also need that arbitrary constant c, right, we're going to write that in to our final line. It's going to be basically 1 over 29 times e to the exponent of 5x times 2 sine 2x plus 5 times cos 2x, close bracket, plus our arbitrary constant c. We need the arbitrary constant because we are integrating this expression. So thus, this here answers the original question for this. Alright guys, this is the end of my YouTube video. Thank you for watching. If you enjoyed it, feel free to give it a like. And of course, as always, I love to know your thoughts about my YouTube videos, so feel free to leave a comment down below. And if you are new to my channel, feel free to hit that subscribe button. Anyways, I hope to see you next time for another math video. Bye!